Hey, how's everybody doing? Today we were going to look at solving similar figures and proportions. We did a video on identifying if figures are similar or if proportions or if ratios were proportional. So today we're going to take that a step further. We're going to look at a algebraic way of looking at it, and we're going to take some more difficult problems too towards the end there. So I hope you enjoyed it. I hope it's helpful. Please make sure that you subscribe, share, comment, all that will help me out. So hope you like it. All right, let's take a look at these few problems that we have here. So as you can see, we're going to look this. We know that they could be proportional, all right, but our goal now is to see how to solve for these. All right, so you have one of two ways. Just like before, we could say, oh, is there something times 7 that could get us 49? Well, in this case, there is. We could do 7 times 7. So 7 times 3 is 21, all right? So x equals 21. Now, that won't always work. I tell my kids that the most foolproof way of doing this is to use the algebraic way, which is our cross product. So we can do 7x, or 7 times x, which is 7x, all right? And then we can do the 3 times 49, which ends up being 147. We divide by 7. And sure enough, it does give us 21. Okay, for our next one here, it's slightly different. So if you notice, our variable is now on the left, but we can do the same process. So we have 5 times 3 does give us 15. So we could simply do 17 times 3, which is 51. All right, so we know that our x equals 51, or in this case is h. Okay. Now, the other thing we can do is our algebraic way, just in case, all right? Because like I said, you can't go wrong that way. So what we'll do is multiply 5 and h, which is simply rewritten as 5h. And then you can see already this makes it a little bit more difficult, but as I said, you can't go wrong here. So this is 255. We divide by 5, and sure enough, we can see that 5 goes into 255 51 times. Now, the last one here, there's no way we can go ahead and do our approach of saying what times 12 can get us 18. Most people off the top of their head can't figure that out. So we have to go with our algebraic way. So 12 times x is simply written as 12x. All right, 10 times 18 is 180. And we know that 180 divided by 12 is 15. So our final answer for this is x equals 15. All right, let's take a look at this problem. This is a great problem. So when it comes to word problems and proportions, I always tell the kids, make sure that you are providing some type of label here. So let's take a read through. The ratio of the number of movies Greg, so we can put Greg on top, has to the number of movies Lenny has, Lenny can go on the bottom, is 5 to 7. Okay, Greg has 75 movies, all right? How many movies do they have all together? So this is where they get you right here. I'm not concerned about how many Lenny has. I need to know the total, all right? So this is enough information to figure this out. So if we're looking for the total here, if Greg and Lenny together, right, 5, 7, well, instead of having Lenny here, 5 and 7 is 12. Right? So let's get rid of the 7, put a 12 in there, all right? And we know that that's our total. I think this is a classic proportion problem. So we can say 5 times what gives you 75? Well, 5 times 15. 12 times 15 will give us our missing number, and 12 times 15 is 180. So the total movies that they saw is 180. Tricky problem, just got to be on top of it. Right now what we're going to do is take that approach, using it for triangles and polygons and missing sides and things like that. So what we're going to do is, we know that triangle ABC is similar to triangle DEF. That has to be stated. So this is missing. So we only need to proportion the two. So makes sense to probably put our x in. All right, x, what does it match up with? Well, it matches up with our 36, so that's going to go on the bottom. Now we're going to go back to this triangle here, and we have an option to pick either 35 or 45. Let's go with 35 since it's smaller. All right, 35 matches with 21. All right, so we can do cross products, right? 21x equals, well, it's going to be a big number here, 36 times 35, which is 1260. Once again, we divide by 21, right? And that divided by 21 is 60. So x equals 60, which makes sense, though, because this should be fairly large. Now, another way we can do this, right, you got to be on point with this, is if we go back, right, because I know sometimes you don't like to use those cross products, right? We have this. Well, we know we can't multiply something by 21 to get 36, but this could be reduced. 35 over 21 could be reduced to 5 over 3, right? Well, we can multiply something by 3 to get 36, which is 12. 5 times 12 is 60. Boom. Now you don't have to do all that extra work. All right, these problems I love because they're always tricky. So you got to kind of see what's going on here. So they want us to find out what W is. So at the very least, we can set up the W. We're looking for this. Now, you don't see it, but we have a smaller triangle here on top of a bigger triangle. So let's separate them. We have this smaller triangle, which I'm not going to draw the scale, but W. And this bottom part here is this bottom part here, which is 16. Then we have the larger triangle, which is all this, is 12 here. And then these two together is 20. So we're going to use these instead. Well, W is similar to the 12, right? We go back to our W, we have 16 is similar to the 20. All right? So we can cross multiply. We got 20W equals 16 times 12, which is 192. We'll divide by 20, which it looks like we're going to get a decimal. And that is 9.6. So that one's a little tough. You may want to watch that a couple times. All right, so that is our lesson on finding missing sides in similar figures and solving for proportions. Very similar to similar proportions and similar figures, except now there's a missing piece, as we said. As you can see, you want to stay very organized as usual. You can either go the route of using the algebraic way to find your missing side or proportion, which is your best bet, or you can use your seeing if one fits into the other, as we stated. And be careful with that last problem that we did. It can get rather confusing. I see that a lot in my math career. But leave a comment if there's something that I didn't do that you would like me to see me do. I'm definitely open to that. Otherwise, have a great day. Good luck.